Hello everyone, I'm Paul and today we're solving problem 3085, minimum deletions to make string k special. This is medium and this can be tricky if this is the first time you're seeing something like this. So here I will show you my thought process, intuition, approach, and efficient solution. So keep watching. We're given a string word and an integer k. And we need to return the minimum number of characters we need to delete to make word k special. And this is how we can make word k special. We need to take the frequency for every character in word and the difference for every frequency in the word has to be smaller or equal to k. So let's say we get this word and k is 2. From this, first we need to build a frequency map. So remember, to build a frequency map, we need to iterate this from left to right, from index 0. So first the I pointer is here, and now we have a D, so we add to the map D with a count of 1. Next we update the I pointer and we repeat the same process. Next we have an A, so now in our map we have A1. Now we have a D, so now we have 2 Ds. Next we have a B, so we add B1 in the map. Now we have a C, so we add C1. Next is B, so now we have 2 Bs. Now we have a D, so we add 1 D. Now we have C, so now we have 2 Cs here. Next is D, so now we have 4 Ds. Next is C, so now we have 3 Cs. Finally we have a D, so this is now 5. Now this is our frequency map and we need to make this word k special, meaning every frequency here needs to have a difference of at most k. So this is not k special because, for example, if we take the frequency for D, which is 5, and the frequency for A, which is 1, the difference between this and this is 4. And 4 is greater than 2. So this means we need to remove some characters from here to make this k special. And more specifically, we need to remove the minimum number of characters to make this k special. So the answer for this example is we can remove 1D, meaning this is now 4. We can remove 1A, so this is now 0. And now we don't have any more A's, and now every difference between this, and this is smaller or equal to 2. And given that here we remove 2 characters, the result for this example is 2. So this is not k special, but if we remove this and we remove this is k special. Let's see how can we solve this. Let's say we have the same input and we already have our frequency map. And we can represent this frequency map like this. For example, we have 5 Ds, 1A, and so on. And this is how we can solve this. We'll take each of these as candidates. So let's say we start with D. We are here. And D has a count of 5. And we will take this as the low bound. So this is our low bound. We will also set a high bound, which will be D plus K. In this case, 5 plus 2 is 7, meaning the high bound is here. So this is our current range. When we take D as a candidate, this is our range. And now we will delete every character that's out of range. Among these frequencies, we are checking which characters are out of range. So let's say we are here at A. A has a count of 1, but our lower bound is 5. 1 is more than 5, so this is out of bounds, meaning we will remove every A. So we'll keep track of this with a variable. We'll call this destroy. This is initially 0. And every time we remove characters, we add those characters here. So right now we are removing 1 character, so this is 1. Next we are B, and B has a count of 2. 2 is smaller than our lower bound, which is 5, so we can remove all of these characters, meaning we add to destroy 2. So this is now free. Finally, we are here at C. C has a count of 3. 3 is smaller than 5, which is a lower bound, so we can remove all of these characters. So we add to our result 3. This is now 6. So when we take D as a candidate, we need to remove 6 characters to make this case special. So our result right now is 6. But we need to return the minimum amount of characters. So we will take every one of these characters as candidates and we will check the same. So now destroy is 0 again, and let's say now our candidate is A, meaning the low bound is now 1 and the high bound is at 1 plus k. 1 plus 2 is 3, so this is the high bound. So this is our range. And now we need to check if this, and this are inbounds or not. First, D has a count of 5, and 5 is greater than our upper bound. And given that we need to remove everything that's out of bounds, we need to remove this in this case, meaning 5 minus 3 characters. So we add to destroy 2. Now we're here at B, and B is inbounds. It has a count of 2 and it's in between 3 and 1, so we don't need to remove anything here. We can continue with C, which is also inbounds. It's right in the upper bound, it's 3. So when A is the candidate, we need to remove at least 2 characters to make this case special. And the minimum between 2 and our current result, which is 6, is 2. So we update this and the result is now 2. Now we are taking B as the candidate, meaning low bound is here and the upper bound is at 2 plus k, meaning here at 4. So this is our range, and we start here. We are checking if D is inbounds or not. The count for D is 5 and the upper bound is 4, meaning we need to remove this character. So we are removing 5 minus 4 characters, meaning we add 1 to destroy. Next we have the A with a count of 1, and 1 is below 2, meaning we need to remove this character, so we add 1 to destroy. Finally, we are checking if C is inbounds, and the count for C is 3, which is in between 4 and 2, so we are inbounds here. So when we take B as the candidate, we need to destroy 2 characters, and the minimum between this and this is 2, so we keep this as the result. Finally, we're taking C as the candidate, so low bound is here and the upper bound is at 3 plus 2, meaning here. So this is our range, and now we are checking if D is inbounds. It's right at the upper bound, so we don't need to remove anything here. We continue with A, and A has a count of 1. This is below 3, so we remove this character. We add 1 to destroy. Next we have a B, and B has a count of 2, which is below 3, so we remove these characters, meaning we add 2 to destroy. This is now 3. And the minimum between 3 and 2 is 2, so we keep this as our result, and this is what we return. Time and space complexity for this approach will be roughly big O of n. So now let's go with the code, and hopefully you will get the idea. First, we need to build a frequency map, so we'll call this freq. This is a default dictionary, and we will set a default value of 0 for every key, so we use the word int here. And now for every character in the word, frequency at that character plus equal 1. So this is how we build the frequency map. The result is initially infinity. We can write infinity like this in Python, float inf. And now for low in frequencies.values. Destroy will be 0 initially, and now for every value in frequencies.values, if the current value is smaller than low, meaning if the current value is smaller than the low bound, we can add to destroy the current value. Else, if the current value is greater than the upper bound, meaning low plus k, we add to destroy the current value minus low plus k. Okay, so if we exceed the upper bound, we need to add the difference between the current value and the upper bound. And finally, we need to update the result. So the result will be the minimum among the result and destroy. And now we return the result. So this is it for the code, and now let's try and submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.